welcome to our first IABP Sea Ice Community Practice meeting of the year. I'm Angela Bliss, a co-lead of the Sea Ice community, along with Ignatius Rigor, Nathan Kurtz, Elaine Runga, and Melinda Webster. And today's meeting is our 2024 Sea Ice Coordination meeting. So today we have 4 great speakers that will be sharing new and ongoing efforts to support sea ice observations this year. And the goal of this meeting is to update our community on plans for the season in order to maximize opportunities for coordination of sample and observation collection, ultimately to help improve our understanding of the interactions between sea ice, the atmosphere, and ocean. So we'll have time for 1 or 2 questions after each presentation, with more time reserved for questions and comments at the end of the speaker presentations. So please feel free to enter any questions you have in the chat box or use the raise your hand feature on Zoom. So our first speaker today is Penelope Wagner, who's head of the Norwegian Operational Ice Service at the Norwegian Meteorological Institute, and she'll be giving us an introduction to Ice Watch.
Great, thank you, Angela, and thank you all for inviting me. I will quickly share my screen. Okay, can you see everything? No.
Yeah, looks good.
Yes, great, thank you. Okay, yes, so I'm Penny Wagner. I'm the head of the Norwegian Operational Ice Service at the Norwegian Meteorological Institute. We're based here in Tromsø, Norway, and so our office is actually specializes in the wind and weather and the sea ice information for the National Met Office. So I'm just going to give you a brief overview. We cover Met Area 19, and this is between East Greenland and Russia. So it's actually an incredibly dynamic part of the Arctic, and we consider this a European Arctic. But I'm not going to actually go so much into our operations. I will focus on the ship-based observations that we work with. But we do provide sea ice concentration to our users Monday through Friday, but nothing on the weekends. So just an overview for the ship-based observations. We find these to be incredibly valuable because we like to use information to help us do a quality control over like various ice regimes, because especially since we actually have primarily first-year ice in our area of monitoring. And of course, the ship-based observations provide the detailed ice information that in the absence of drill measurements or, of course, aerial reconnaissance, so primarily the concentration, the thickness, and the surface topography. And we actually find this very valuable because it's useful on the scale that we need them. We actually, in working with the World Meteorological Organization, Global Cryospheric Watch, we acknowledge that in order to use proper ice observations for our quality control, they're going to need to be in a Lagrangian style type of measurement following the ship's track. So it could be ship-based observations or buoys and such, because it's very difficult to have routine sea ice measurements due to the drift ice. And of course, there's another, oops. Can you see that okay? Yeah, I think it's, you can see here's an example of sea ice from the bridge. You can see various different ice regimes. We can also use the ship's radar to look at icebergs. And then, of course, looking on the right-hand side, you can gauge the sea ice thickness as the ice is being broken and turning over. So you can get a lot of information from these ship-based observations, but there's a lot of challenges because this is incredibly resource intensive for us, for anyone. I think this is better. Okay. So for those of you who are familiar with Ice Watch, this was a program that was developed at the University of Alaska in Fairbanks. We have been working with Jenny Hutchins and the group there with the administrative tasks. But in 2019, we decided to host it over at the Norwegian Meteorological Institute because we actually thought that it would actually have more of a stable home being associated with a more government institute, and also because we work directly with a lot of end users. So we are actually expecting that the uptake capacity would increase because we deal with a lot of researchers. We deal with the Coast Guards and many other operations and ships that go into our area. And of course, one of our biggest industries is fishing and polar tourism. So you can see it's from 2019, it's been transferred over to us and we're maintaining it. And since then, we were able to develop an app for this from some ESA seed fund. And it was actually working with the Polar Citizen Science Collective. And they actually developed them. And so it was about a 1.5-year project or so. So we got to a beta test on this. And so actually we did a testing with citizen science with some tourist vessels, but then COVID happened. And so we actually lost a lot of momentum during this time, but you can see that the Ice Watch Assist program allows the users to record information such as the ice concentration in different stages. Also, of course, not limited to, but sea ice thickness, looking at snow, looking at surface topography, looking at areas of deformation and leads, and a lot more parameters are taken mainly when there are vessels that are going out for research. So this is not something that commonly is done with operational vessels because they're going through the ice, looking at a one nautical mile radius around the ship, and it's going very fast. So I think it's every ship that goes through ice takes ice observations. So this is just one program of many. And this is also, this is the Arctic version that's compatible with the aspect that's focused on the ship-based observations for the Antarctic. So they're cross-compatible. And Ice Watch is very well known in the Arctic, and a lot of research cruises that go up there use it. We actually have a long archive that goes back to 2006. And we do have a link with the WMO ship observations team that's linking with the voluntary observing ships. We're currently in the talks right now with them, and we have been because the WMO has been going through a restructure, but this is going to be really important for us. So of course, again, these observations are very important, but the software that we transferred over is very much antique, and we need to update this. We actually need to rebuild the whole system up in Python. So here's just an overview of how we would use these. If we were to get ship observations in near real time, we could use them to actually put into our daily ice charts, because we also have the same system with our station at Hopen, Bear Island, and Jan Mayen. We have people who winter over there, and they provide observations for us on a routine basis when there's ice in these areas. We also work with polar code training, so it's useful to have the archive of ice observations since the polar code is so vague, and this is something from the International Maritime Organization. And we, of course, use these observations to QC training sets that we're using to do automation. So you can see what we're trying to do. We would really like to have a lot more information because we need a lot of data. We need a lot of sea ice data to do CalVal for satellites, so we can start moving towards a more semi-automated analysis for our ice analysts, because right now our ice charts are done 100% manually. And I think most ice services are like that as well. So you can see we would like to have an ice water classification. We want to include the stage of development in our ice charts, because right now we only have ice concentration, and we're looking at doing classification of flow size distribution because we're looking, we're right now evaluating the skill on many of these different forecasts, short-term sea ice forecast models, and we would like to use a lot more improved automation to make these a lot more useful for our analysts. So of course, some of the challenges, we don't operationally use ice observations from Ice Watch right now, and we have tried numerous times, but because the point measurements and the ice is drifting, it's actually very difficult to coordinate this, and also with a lot of satellite passes. We use primarily synthetic aperture radar for our ice charts, and it's very difficult to combine the observations on the scale that we need. Also, the amount of quality control that is necessary for these ship-based observations is also resource intensive. The training that goes into the ice observation is intensive. And we know that there's a lot of archives that even operators could take, because not everybody, we don't think that everybody needs to use IceWatch, but I think there's not really a systematic way to ingest ice information and have this feedback loop back to ice services or even citizen science and such. And then the frequency of observations, it just doesn't, because of all these other challenges, the uptake frequency is very low. So this really strains our ability to use this. And I think we find out that there's actually a lot more automation that's necessary, including the apps and camera work. You can see here's a schematic of how we would actually view the use of ice observations. The gray area, say the green area is when we would get the input in, whether you have a trained observer or not. But the gray area is where we would actually use a lot of work for us, because we would need to make sure that the data is scalable, that it has a high quality control, that it is able to be integrated into a standard format, into our ice charts or into a repository that others can use for even CalVal or training for that purpose. And we would also, of course, need to make sure that this is accessible and that it is able to be ingested into other sources. So these are very challenging if you're not getting the data, all the data you need, and if there's no automation set up for this. So the future, what we would like is to really help to develop some better automation, including expanding the app so people can use this, and then we can have actually help with the quality control, provide more resources on our side to do this before we actually allow it to be sent out. There is also the issue of trying to get all the other observations from different logs into these types of repositories, and a lot more robust training for the ICE observers. Ideally, so we would like to link with the WMO because they are responsible for the global telecommunication system, the GTS, and this is where we get a lot of the observations for oceanographic or weather. This goes directly into the models at the National Weather Services. We would like to actually have this for sea ice, but it's not available. But they do have the setup for at the subarctic levels. So that's all I wanted to say about this. I know this was really brief, but this is our information, and I hope that was helpful.
Thank you, Penelope. That was great. Do we have any questions from the audience?
I have one. I was trying to figure out how to raise my hand, though. Should I just?
Yeah, go ahead.
Penny, would
Yeah.
obs from flights over the Arctic be useful?
I'm sorry?
Observations from flights?
Yes, absolutely. They would be. We actually haven't had experience to put it in here. I mean, what I wanted to say is actually we could put it in here. That would be great, but ideally I would actually suggest that to think at a more higher level that there needs to be a common repository. We could use IceWatch, that's fine, but I would like to make sure that these observations go somewhere that everybody can use without having to contact us directly all the time. But yes, we could use those, and that would be really helpful to figure out how we could convert these into a more standard format, because these ice observations are in CGRID 3. Oh, Ignatius, you're muted, I think.
Oh, yeah, I'm good. Thanks.
All right, thank you. So we will again have more time for questions and discussion at the end. But our next speaker is Ignatius, who will be telling us about chasing icebergs and also new plans for IABP this year.
Hello, everybody. Let's see. Hopefully you can see my screen.
Yeah, looks good.
Cool. Yeah, and so I'm not going to go through everybody that's contributed to this presentation because there's a lot. And in the interest of time, I have some people listed here and then acknowledge some of our funders at the bottom. Uh-oh, come on. This is what the buoy network looked like in January 19th, 2024, like a couple weeks ago. You see a lot of buoys headed towards Fram Strait. Quite a few that were deployed in the Beaufort are approaching the North Pole, but you see some pretty big gaps in these areas, which we were trying to fill with the first flight, which happened a couple weeks ago, and then, during the next few months. My main thing to talk about today was our January deployments from the Air National Guard. Our Sofia might show hopefully will show an updated version of this map, but we try to tag, in addition to refilling the Arctic buoy network, we also try to tag some flows of interest for the upcoming Navy ice experiment in a couple weeks, going into March. And then also there's been quite a few icebergs in the Beaufort that we've been tracking. The Canadian Ice Service has done this for quite a while, but we're now seeing more of these in the Beaufort, and given the size and number that we're finding and realizing are out there, we wanted to tag them to see where they're going and, mark them as a hazard for navigation. These icebergs are shown as yellow dots on the map there, which might be kind of hard to see, but I'll hopefully zoom in on a couple slides. So this is one of the icebergs seen last October 2023, from, I think it was the Louis St. Laurent. This is the top map is a map I got from Adrian White from the Canadian Ice Service. These are the icebergs they've been tracking. And then the lower map is from Mary Beth Schreck at the Alaska Sea Ice Program. Lots of icebergs in the area. We don't know where these go, and so tagging them was pretty high on our list. So we flew with the Air National Guard in January. This was a wonderful flight because it's like the first time the Arctic buoy program has ever done any deployments in the winter. They have a 4,000 nautical mile range. We got 2 flights. Focus was mostly the icebergs. And the second day, and then the first day we were in the ARCSIX area upstream. So this is one of the icebergs we were trying to tag on the left. This is a radar image. But the icebergs just pop out in the mosaic of sea ice out there. On the radar, on the right side, you can see where we thought the buoy or the iceberg would be, and that's our planned buoy drop. But as I got used to staring at the radar and realizing what I'm seeing, we actually flew out to this spot that I'm circling right now, and basically we saw a bright reflection on the leading edge of the iceberg as we were approaching it, and then a shadow behind it. And so we flew out in that direction thinking that's probably where it was, 10 miles off from where we thought it was, but there's the radar has a range of 50 miles. So it was, once I started getting used to what I was seeing on the radar, we flew out to this point, and lo and behold, there it is. This is a video from a GoPro at the back of the plane. This is an ARCSIX air buoy built by the Norwegians, and there's the iceberg. This one was 4 kilometers long, a relatively easy hit for the C-17. We dropped this buoy at 1,500 feet. We could fly lower if we wanted to try to hit it, but in this case, we were worried about the parachutes opening up in time, so we flew high. This is left side is a picture of the iceberg as we're swinging back around, and on the right side is a later image that we collected showing the position of the buoy on the iceberg. The timing of the image is like in the middle of the hour, and so the buoy is actually somewhere between those 2 cyan dots. In total, we dropped 27 buoys, lots of ice balls, which is our standard cheap buoy, which is shown on the first picture on the middle, and then the ARCSIX air. And then we also dropped a few prototypes, some of Jim Thompson's micro swift buoys, and then we also have some micro met buoys that Cy Keener at University of Maryland's been building. As I mentioned earlier, this is a wonderful first wintertime deployment for the Arctic Buoy program. And then our next flight with Air National Guard is in July 2024. Let's see, so this green line is the ARCSIX line that we flew. 11 buoys on that flight, actually 16 buoys on that flight. And then on the 25th, we flew the cyan line tagging the icebergs. Right now, the drift is pretty weird. We're not seeing the Beaufort Gyre. Everything seems to be headed straight for to the North Pole and Fram Strait. But hopefully these green dots will flow closer in with the Beaufort Gyre and be closer within reach of the upcoming camp. And this last map is our plans for the rest of the year. We have lots of flights and ice camps coming up for the spring, which are the most of the blue lines. And then red is ice. Oh, I see what I'm doing. Blue lines are flights. Red is icebreakers. And so we have flights out skirting the edge of the Russian EEZ planned for July. The Royal Canadian Air Force will hopefully fill the northern higher Arctic gaps. And then lots of buoys on the icebreakers that are in areas where we have gaps. Thank you.
Thanks, Ignatius. Do we have any questions? I have one. Do you know where these icebergs are originating?
I think they're coming in from Ellesmere Island, which is here. And in the prior map, you can see that there's let's see, this map. You can see that there's quite a bit of basically coming out of this number 4 block. But there's also, I'm not sure how they're getting into the Queen Elizabeth Islands. I'm thinking they come from Ellesmere also. But there may be a source there too, which I'm not familiar with. I'm an iceberg newbie.
Great, thanks. Other questions for Ignatius? It looks like we have a question in the chat. I was wondering what parameters these buoys measure.
Most of the buoys measure air pressure and temperature, which are the basic variables we need for weather forecasting, but they also have GPS and report by iridium. The micro swift buoys are geared towards measuring waves at high frequencies. This was more of a test for those buoys to see, how well they would survive an airdrop. And then the micromet buoys, that's actually, they're basically a long tube. Our long-term plan is to possibly put thermistor strings along the edge of that thing. But also to drop it out of P8s. And so basic meteorology, but also GPS for ocean and ice circulation and iceberg tracking. And all this data is available on our web pages. We try to put as much as we can on the GTS. So it's available to the operational folks.
Great, thank you. Our next speaker is Sofia Montalvo, who's Operational Technical Director at the U.S. National Ice Center.
It's sharing in a weird way, but can you see that okay, or should I share it in a different format?
We can see the slides okay.
Okay. Good afternoon, everyone. I think I have a few too many slides, so I'll try to be quick. And I'll quickly go over the USNIC services to the U.S. government-funded Arctic activities. Quickly, as many of you already know, we are a tri-agency here at the U.S. National Ice Center. We fall under and align our operations under the 3 guiding documents from the U.S. Navy, NOAA, and the U.S. Coast Guard, with the umbrella documents coming from the White House with the Arctic strategies and the implementation plans that have come out in the last year. Our mission is to provide global and tactical ice and snow products, ice forecasting, and related environmental intelligence services to the U.S. government. This is actually a pretty good outline for what I will be presenting to you today. So I'll go into more detail on all of these items here. So I'll quickly move ahead. To do our global and tactical scale analysis correctly, we need in situ observations. Ignatius already went over this, but we do co-manage the Interagency Arctic Buoy program with Ignatius and provide some funding for buoys and data and analysis for him to deploy the buoys at the right locations alongside Mary Beth and Adrian White from the Canadian Ice Service, providing him with those positions for the icebergs. Sadly, I don't have that same regional chart that he showed showing the icebergs positions currently, but they continue to move westward and slightly northward as well. Our bread and butter and our favorite source of data is synthetic aperture radar, especially these commercial satellites, RadarSat-2, C-band, ICEYE, SAOCOM, and then some other electro-optical commercial satellites. With this, since it's commercial, we can actually pinpoint and acquire these images over the missions that we support directly, which is really useful to have that tasking ability in-house. And then our other primary and secondary sources of satellite imagery are from the open sources from Sentinel-1 and 2, the RadarSat mission, Spheres for visible imagery, and ASCAT and AMSR and other geostationary satellites around the world to create these daily and weekly products in-house. This is a good view of our daily and weekly products over the Arctic. The first image there is the Arctic marginal ice zone product that we produce daily. And then the middle chart is ice concentration, and the third chart there is the stage of development product. With all of these, we take all of that data, we take it and we apply and categorize the ice into these 2 to 3 formats. The last two are a combined set that then we pull out the data and create 2 different maps for easy visualization, but it's all in SIGGRAPH 3 format for that. To create robust forecasts for our reports and our daily 48-hour forecast, we need as much model data as we can get. The green lines are from the Fleet Numerical Meteorological Oceanography Center, FENMOC. It's a Navy models. And then the blue line is from NOAA's EMC. It's the ARCSIX model. And then the 3 yellow lines are from Environment Climate Change Canada. We do data share with those models there. And then the last 2 lines in orange are experimental models that we are utilizing in-house, but we can't rely on fully as they're not operational technically. But that 6-month outlook at the end, at the bottom there, is something that we are excited for and looking into more. So converting our products and all of the synthetic aperture radar data we get in-house to these composites, we really appreciate the work from NESDIS's Center for Satellite Analysis or Applications and Research, and their water surface. I have it written down. Their water surface condition branch. They convert all of our synthetic aperture radar data into composites. So to make it easier for our analysts to use, rather than pulling in hundreds of images, they can pull in a single or a few composites over time. And then they also take that data and create sea ice drift products based on images that are co-located 12 to 24 hours apart. And that helps us know how the ice has moved and any possible areas of divergence or convergence for stresses and strains in the ice. They are also helping us make some more efficiency, like Penny had mentioned. Our analysts do all of this by hand. So NOAA's STAR and NGA is helping us create an algorithm to have a first look at the synthetic aperture radar data so that we can then focus more on our increasing demand of tailored and tactical support products that I will be going into now. This is a quick look at some of the many requests for support that we have had over the last year over the Arctic, not including any of the ones over the Antarctic. So our main supports have gone to Coast Guard with Coast Guard Cutter Berthoff in ice avoidance, and the Healy, and I'll show you a slide on that. Pacer Goose with the Pacific Space resupply. Supports to Ignatius, and then the big one coming up, Operation Ice Camp, or ARCSIX, as it used to be called. We're sending analysts up to Alaska very soon. So our direct support to the Coast Guard Cutter Healy, we actually had 2 of our analysts go, not at the same time, but the first person, Brittany Fajardo, went in the summertime for their first deployment as supporting the AMOS mission, and she's standing next to a Wimbo buoy, I believe, on the ice, and then Izzy went on the Northern Sea route, the transpolar route there, providing direct support and briefing the captain and the ice pilots directly daily on the ice conditions and what to expect. And then also providing, if you see that bottom image, that's a very detailed look at where there are weaknesses in the ice so they can transit it more easily. And that was put directly into their navigation system with some caveats of ice drift that the ice pilots were provided. We also supported SASE, salinity and stratification of the sea ice edge. For the Wolstad, they needed to avoid the ice as much as possible, but to get as close as possible to get all of the information they needed from the ocean around the sea ice up north of Alaska there. And this was provided daily. We also supported the research vessel Sikuliak with their support of the ONR's AMOS mission. Again, they were trying to avoid as much multi-year ice as possible, as they are not capable of breaking that thick of ice. And we actually collaborated directly with the Alaska Sea Ice Program to send one of their analysts on board, as we were a little tight on analysts here. But we provided him with imagery, and he provided direct support just like our analysts did on the Healy. And then another big one that we supported weekly with some planning products off season, and then daily whenever the Sikuliak went up to service the moorings, was the APL and NSF funded Coastal Ocean Dynamics in the Arctic. Their moorings were along the fast ice, along the north shore of Alaska, studying those conditions that affect erosion on that coast. And then lastly, naval operations in and near the ice, actually second to last, are increasing. And so we have so much more demand on our time and for ice avoidance and to exploit as much of the Arctic as possible. And then Ice Camp coming up in March. Again, you can see the USS Pasadena broken through the ice there in 2022. That will be happening again this spring and every other spring going forward. And then quickly on our collaboration and coordination with Alaska Sea Ice Program. We work so closely with them. We try to be as seamless as possible if you're looking at their analysis or our analysis. So we have weekly coordination calls. We share areas of responsibility and make sure that the support we're providing, we either share responsibility for that tailored support, or we make sure that one or the other, we're not communicating different things to the operators up there. And that is all I had.
Excellent. Thank you, Sophia. Do we have any questions? right. In the interest of time, let's go to our final speaker today. We have Linette Boisvert, who will be giving us an introduction to ARCSIX and the ARCSIX surface characterization overview.
Thanks. Okay, let me just share my screen. All right, and I'll make it full screen. All right, can you see it, my screen? Okay.
Not in presentation mode yet.
Okay, it is for me.
There it is. It looks
Okay,
good now.
Okay, thanks. Yeah, so hi, I'm Linette. I'm going to talk about the Arctic Radiation-Cloud-aerosol-Surface interaction experiment, or ARCSIX. And I'll be focusing mostly on like the surface characterization portion of this campaign. So the overall goal of ARCSIX is to quantify the surface properties, clouds, aerosols, and precipitation to the surface radiation budget in the Arctic in the summer, and also how all these factors affect sea ice melt during the melt season. So this will take place in a two-part airborne field campaign based out of Pituffik or Thule, Greenland. And the first campaign is planned for late spring, so May 23rd to June 15th. And the summer campaign is planned to take place July 29th to August 17th. And there's basically three main factors, I guess, driving the need for this campaign. Basically, we want to understand how the coupling between the radiative processes and the sea ice influence summer sea ice melt. We want to understand the Arctic cloud regimes in the summer months and their properties, and also improve our ability to monitor the clouds, radiation, and sea ice properties from space, and also improve climate models or modeling techniques as well. So there's three main portions of ARCSIX. We have the radiation portion, which they want to know the impact of the radiative budget on the surface energy budget for the Arctic. The cloud life cycle group wants to understand what processes control the evolution and maintenance of the cloud regimes in the summertime Arctic. And then for the sea ice group, we want to better understand the two-way relationship between the surface radiation, cloud, precip, and surface properties, and how all this ties into the seasonal evolution of the sea ice in the summer. So we're going to be based out of Thule or Pituffik, Greenland, for these two campaigns, and we're actually going to have three planes. We'll have a low-flying P3 plane, which has about 175 flight hours, and we're also going to have a high-flying plane, the NASA G3, and then we'll also have the Canadian Learjet as well. We plan on using lots of different satellite images as well, both active and passive satellite, and also some real-time numerical weather prediction forecasts using the CAFS model throughout the campaign as well. So on the high flyer, or the G3, we're going to have measurements of temperature, humidity, and wind profiles using drop suns. We're also going to have an imager, which is Avris NG. Also be able to measure vertical profiles of aerosols and clouds, and get information on the clouds, the cloud boundaries, amount, and phase. And the low flyer on the P3 will have a suite of aerosol microphysical measurements, as well as meteorological measurements like winds, temperature, water vapor. Also have cloud microphysical and properties, trace gases, and short and long wave radiation measurements as well as albedo and BRDF. And then for the sea ice properties, we'll take measurements of the temperature, the freeboard, flow size distribution, and melt ponds and melt pond distributions as well. So here's just another figure showing kind of the two different planes and some of their capabilities. You plan to fly the planes in tandem with each other, with the high flyer taking more like curtains of information and dropping drop zones, whereas the P3 will take more in situ type measurements, much lower to the ground. And we plan to target clear sky conditions, especially for to measure the sea ice properties. We also want to focus on thin layer clouds and multi-layer clouds, potentially look into some air masses that get transported into the area and how they are modified, as well as the local interactions between the lower atmosphere and the surface. So for the sea ice, there's two kind of science questions that we want to look at for ARCSIX. The first one is, how does the evolution of the sea ice properties affect the clouds, the air mass evolution, and the near surface temperature and humidity structure throughout the melt season? And also we want to determine what the combined impact of the initial surface conditions, as well as the changing atmospheric conditions, how does that affect the evolution of the sea ice through the melt season? So basically, we want to use our airborne and satellite measurements of all these properties of the sea ice and monitor like the same ice throughout the summer months. So how are we going to do this? So one of the ways we're going to do this is we're deploying 10 ice mass balance buoys in the Arctic in April of this year. And so we're hoping that we can deploy them about 200 nautical miles north of Alert and Station Nord in these kind of two little arrays. And they'll drift about 20 kilometers per week. And our plan is to repeatedly fly over these buoy arrays in the different campaigns when we have clear sky conditions. So we'll know where they are based on their GPS and some of the conditions that are seen at the buoys as well in between the flights. So these buoys will have snow depths, temperature, pressure measurements, upward and downward looking rangefinders for like the radiation parameters. Also have an ocean ice atmosphere thermistor string and GPS. And then Jack Landy and the Iceberg team are going to be providing some MET stations to go along with these buoys, and they'll have wind speed and direction, temperature, pressure, and humidity, as well as the GPS. So in order to capture the changing surface conditions, we want to kind of revisit these same ice flows throughout the campaign. So in April, the buoys will be deployed, and before the first campaign, we'll monitor the conditions at the buoys as well as using satellite data and other imagery to get the conditions prior to the melt. And then during the first campaign, we hope to capture the evolution of the surface from pre-melt to melt onset. And we hope to revisit the buoys at least once a week via our aircraft to measure the buoys and the surrounding areas, and also do ISAT-2 coordinated underflights. And then in between the two campaigns, we still plan to monitor the conditions at the buoys using the measurements from the buoys, as well as using satellite data as well, to kind of understand what's occurring when we're not there. And then coming back in the second campaign, we want to kind of capture the surface evolution from the height of melt to potentially the start of freeze up, or when some of the melt ponds begin to freeze over. And again, try to revisit the buoys once a week during this campaign to capture this transition. So here's just like a sample flight plan that we made up, looking at some satellite imagery from back in May of this year, hoping that we will see similar conditions. And basically, the hardest part for ARCSIX is trying to put to achieve as many science objectives in each flight, because we don't have that many flights and we have lots of science objectives. So this flight shows this flight plan shows the P3's path in red and the G3 in gray. And basically in this flight, we've planned to do some really low level aerosol sampling around alert and an overflight of alert, which is like the waypoints 3 through 9 for the P3, then go up and measure the buoys. We just guessed that they might be in this area. And we'll do some albedo measurements and surface property measurements like the freeboard and aerial photography as well. And then when we transition home, we would fly on this coincident ISAT to ground track to get some measurements with our laser and also with ASAT-2. We're also collaborating with the Norwegians doing iceberg measurements, and we'll be doing some coordinated flights with them out of Station Nord during our second campaign. And we've also been talking with the Swedish icebreaker Odin, and they're doing a campaign just north in the Lincoln Sea, where we'll be flying lots of the time. So we're going to hopefully overfly their ship as well. And we're also talking with people at Alert and Willem in Station Nord to potentially do some overflights of them as well with all of our measurements on board. And yeah, so if you have any other questions, please reach out, and thanks for letting me share.
Thanks, Linette. So it looks like there's a couple of questions in the chat. One from Ben Reeder. How did the buoys observe snow depth?
So they have like a downward looking rangefinder, I believe, that measures the snow depth, and so it measures like the height of the snow on the surface, and as that changes throughout the lifetime of the buoy. Yep.
Okay, and then one more.
The last one from Chip. Yeah, so there are about maybe not 15 flights per campaign, but the 15 flight hours were just to be dedicated to the surface characterization portion. So flying over the ice and the sea ice portion of the campaign. Yeah, sorry for the confusion.
Great, thanks. So I guess we'll use the rest of our time for group discussion. So I think Nathan will take over.
All right, thanks. Yeah, I see. I mean, we've had a lot of questions in the chat, but now that we have, I guess, not as much time as we initially thought, but if there are other questions for the speakers or just discussion points, given all the talks that we've had, just open the floor here.
Sorry, actually, I was trying to find the hand option. I don't know if there is one. Can I ask a question though?
Yeah,
I see. I was actually, and also in response to Chip Miller's question, and Linette's presentation. Thank you very much. We've also, it seems like there's a lot of campaigns that are going on in these same areas this summer, and actually, because we've been asked so that we don't double efforts with the satellite overpasses and stuff. And I actually thought, because of course, like we work with Jack as well, Jack Landy, and we're very interested in looking at this, the Cryosat and the ISAT and the collaboration, because we can also get some of the Cosmos, like the L-band stuff too, and have really good overpasses over these areas. So we're in the process right now of coordinating with all the other groups that are doing the satellite coordination, so that we don't double efforts and we can actually kind of like share these areas. So I'd like to know if, I guess maybe after this, what's the best way to contact that? Because we were supposed to figure out from the US side in Canada who is doing that. We had a few links to with the RCM and with ONR and stuff, but we actually just started. We're on the beginning stages of this.
Would this be, I guess, a question especially towards the ARCSIX and the ARCSIX and Iceberg kind of?
I don't know. It seems it's. I mean, maybe a lot of folks here can. I don't actually. I guess maybe the ARCSIX potentially, or is there another body that could help coordinate all on the North American side as well? Because I'm sure it's not just ARCSIX and working with maybe the National Ice Center, or I'm sure there's some more common coordination with the satellite.
Is Frank Reck still on the call? Okay, so Frank was on earlier, but the NASA, NSF, and I don't know which other US agencies have been using Polar Geospatial Center to collect images. And so I just submitted a broad request for all sea ice folks that I kind of knew were interested in images.
Okay.
But PGC is collecting these. And I don't know, I was hoping Frank was still on to tell me if they're actually funded to collect more. But yeah, that's my go-to for random satellite images that I can't easily get from, from
Okay.
other sources.
But I guess maybe some of the other groups who are interested in more CalVal would be interested in the coordination of these. I mean, like for example, like Jack and the ISAT and the University of Maryland group, especially trying to get scheduling passes over these areas around the time of the campaigns.
Yeah. Yeah, because I think from ARCSIX and other field campaigns, there's an invaluable data set where, people are landing on the ice. Chris Poloshinsky could take a lot of observations and really characterize the area.
Exactly.
That would be invaluable for the remote sensing teams. And I don't know if anybody is funded to collect all that. It's a treasure trove that should be collected.
I guess I would like to know who to talk to help with coordination, because I'm on the remote sensing side myself, so I'd be the one to take the observations for the CalVal for us.
Yeah.
And I know my understanding, at least from the NASA side, and Linette, you can chime in here too, like from NASA and ARCSIX, it's really just through forums like this or talking with people. Oh, you're out at this time. Oh, we are too. Okay, let's coordinate. I don't think we've really had like a good centralized effort, other than maybe what you mentioned, Ignatius, with PGC, where it's like, okay, everyone's going to that same spot, but
okay.
I think there's a bit to be done.
No, but this is good to know that it's good to know, so then I can also contact you all afterwards and Sinead and folks. Yeah. Great.
Yeah, and I don't know if this is like a WMO cryo watch thing that should be brought up. I think if there was like some higher level WMO IOC request for somebody to set up something like this, I think the international governmental agencies will, it might be easier to fund something.
I mean, they wouldn't, the thing is, no, I mean, I think that's kind of out of the remit. I think for us, because, with us and especially like the national meteorological agencies here, we actually have a quota and we try to coordinate our passes so we can share data with one another. And I think, like, for example, I said, with this Horizon Europe project that we could potentially collaborate with, we could help with the satellite passes and the coordination, but actually it's maybe linking everybody else who's already providing the satellite data and connecting with some of the in situ observations. And then we could actually even provide that extra like added value. Because all of us are already getting the information from, say, Copernicus and such. And so it's actually just maybe helping to organize this in a more systematic kind of way so that we can really link these observations with the satellites. And also the different sensors like the C-band, the RCM, the L-band, potentially the X-band. And of course, like the altimeters. That's what we would like to see. We would like to actually see a multi-frequency CalVal system, because we are trying to really do some proper automation for these sea ice classification things before these satellites really go up operationally in 2028 for the European space, for ESA.
Another form that might be able to do this is ice paper. It's more of a DoD thing, but there's a big remote sensing group there.
Yep.
That's
exactly. We were actually going to contact, yeah, I mean, like we were going to contact the ONR and the ICE PPR such, but it seems, I guess for me, it's if there's not already some kind of remote sensing coordination going on, like in a bigger scheme, then we should contact ICE PPR and bring it back to this group and
I'll
see
send
who's
an
doing
email
what.
I'll send an email to Lee Stearns, who's like the lead for the remote sensing part of ice paper. And I'll
Lee
see
Stearns out of Kansas.
Yes.
Yeah, it's actually, because she's working with iceberg tracking tasking with ISCWG with us. So that would be great if you could link me in with what they're doing with these campaigns, because I don't think she knows that we are interested in helping to coordinate the satellite acquisition and sharing data.
I think that might be the best route, at least a really good route forward.
Okay. That would be, that's good. ICE PPR though, is that not only for icebergs though?
No, it's a remote sensing. Lee Stearns, like all the icebergs I'm tagging, I'm sending her the data. She put some tags that I sent her in Sermelik Fjord. So there's a lot of sharing.
Okay.
But yeah, there could be more.
But good to know. Yeah,
more
that would be
coordination.
great. That would be great. That would be great to do that.
Yeah.
That'd be really helpful. Like I said, we just had this meeting 2 weeks ago to talk about this, and look, with all these like coincident campaigns going on in these same areas. So it's a really great opportunity.
Yeah, and possibly with IICWG coming up, 6 months from now, it might be another good place to bring this back up. But I mean, we should pursue it now.
Yeah. Agreed. Sorry, Nathan. I think I overtook.
Oh, yeah, sorry.
no worries.
I have to go to another meeting, so they're calling me right now. But yeah, thank you, everyone, for the discussion. This has been good.
Thank you, everyone.
Thanks all.
Thanks,
Thank
everybody.
you.